This time we're back in section 9.3 for problem number 86. We hear that listening to Mozart improves students' performance on test. Maybe pleasant odors have a similar effect. To test this idea, 21 subjects worked two different but roughly equivalent paper and pencil mazes while wearing a mask. The mask was either unscented or carried a floral scent. Each subject used both masks in a random order. The table of data is given in the book with the subject's times in seconds with both masks. Note that smaller times are better. Do these data provide convincing evidence that the floral scent improved performance on average? So first, again, we're going to start with writing our null and alternative hypotheses. We're looking at if there's convincing evidence that there is a difference between the two scores. If we have the mean score for one, the mean score for the other, if they're equal, that difference should be 0. So we're going to write our null hypothesis to be mu of the difference is equal to 0. Then our alternative hypothesis would be mu of the difference is less than 0, where we're going to define mu of the difference to be the true mean difference if we do scented minus unscented, and time it takes to complete the mazes. With the masks on. Make sure you're very specific in how you define your parameter. Then again, as always, we're going to set a significance level. I'm going to set 0.5 again because I really have no reason to do otherwise. Check our conditions. Now, we don't know necessarily if there was an S or S taken, but the randomization here came from the fact that they randomly assigned the order of the masks. So we had random assignment of order. Then we want to check our 10% condition. Well, in this case, we know that they're all independent, so we don't even have to worry about checking the 10% condition. So we'll go straight into our large counts condition or normal distribution. We don't know normal. We also only have 21, so we wouldn't be able to use the central limit theorem. So we're going to go to that data. Now, all this data is given in the book. I just took the data in the book and entered it into my calculator into list L1 and L2. Now, to get the difference, I'm going to go up to L3 and I'm going to define it. Now, we are doing scented minus unscented. Scented was given in this second column, and unscented was given over here in the first column. So I'm going to do L2 minus L1, and that's my definition for L3. Now, auto fills all of L3 to do L2 minus L1. So after I do that, I'm going to look at a stat plot. I'm going to go ahead and look at a histogram this time. And that histogram is of L3 because that's where I have my data. And then I'm going to press zoom 9 so it automatically zooms in. And remember, we're looking for strong skewness or outliers. And there does not appear to be strong skewness or outliers, so I can continue on. But again, I want to draw that in as part of my answer. It can just be a quick sketch of what you see on your calculator. So I'm going to give a rough sketch of what I saw on the calculator to be able to display that there was no strong skewness happening. So the graph shows no strong skewness. Or outliers. So we are going to use a one sample t-test. I'm going to use technology this time to do that t-test. So remember, in the calculator I can press Stat, move over to Tests. I am doing a t-test. I have my data. My mu naught is equal to 0. I have the data in L3. Frequency is going to stay 1. And then my alternative hypothesis is a less than. Then I'm going to hit Calculate. I'm going to write down what I get out from my calculator. So using technology, I get t is equal to negative 0.349, p is equal to 0.3652, my degrees of freedom is 20, I have an x bar of negative 9.567, and I have an SX of 12.548. So our 0.3652 is definitely greater than our 0.05, so we would fail to reject. And as always, we're going to give that answer in context. We do not have statistically significant evidence that the floral scent improved performance. All right, that's all for Chapter 9.